Hi guys, so this video is going to be on graphing tangent. I'm going to start by just doing a little recap of cotangent from yesterday's video. So for my vertical shift for this guy, I am down 2 with that guy. My horizontal shift, I am right pi over 2. My amplitude is 3. Now remember, the key change for cotan is that now it's just pi divided by b for your period. Right? So this is my b value. So if I take pi divided by 2, that means my period is pi over 2. My quarters are going to be pi over 8. So I start at pi over 2. Okay, now pi over 2 is the same as 4 pi over 8. So this would be 5 pi over 8, 6, 7, and then 8 pi over 8, so pi. So remember, the two ends of cotan have the vertical asymptotes, and their pattern was 1, 0, -1. So if you would put 5 pi over 8 in here and evaluate cotan out of this portion, you would get 1. So times 3 minus 2, you get 1. If you put 6 pi over 8 in, you would get 0. So this is just -2. And then if you put in 7 pi over 8, you would get -1. So this is -5. So pay attention and watch your scale here. So we're counting in eighths. Okay, so this is 4 pi over 8, 5. Sorry, this is smushed. Okay, so I have a VA here and here. All right, so at 5 pi over 8, I'm at 1, and then here, -2 and -5. Remember, you got to hug your asymptotes, but you don't want to be too much like this because that wouldn't be really indicative of a function. We got to keep this smooth. Okay, so then we just need to list our domain and range. Remember, the range was all reals for this guy. Now our domain, you list x cannot be wherever your first asymptote is, so pi over 2, plus it reoccurred at the end, so that means a full period away. So it's plus your period, pi over 2 times k. All right, so let's get into tan now. So recall that cotan theta was x over y. Tan theta is y over x. So let's come over here and look at some values for both of those. So for tan, let's do cotan first, sorry. For cotan, okay, if we would put in, and I'm just looking at the values that we got from yesterday for the generic cotan graph. If we looked at 0 and pi yesterday, we said that those were undefined, so those were creating the VAs. This was 1, 0, and -1, and we got the pi over 4 and 3 pi over 4 from the 45, 45, 90 triangle. Okay, so now let's look at values of tan. Okay, so if you look at tan of 0, so 0 would be here, and remember that tan is y over x, you would have gotten 0. You would do pi over 4, which is 45 degrees for tan. Tan is opposite over adjacent, you would have gotten 1. And then when you go to pi over 2, so pi over 2 is located here, y over x would have given you undefined. So that's where the VA is going to be for tan. If you would do 3 pi over 4, so it's still a 45-degree angle, so 1 over 1, but 3 pi over 4 is in quadrant 2, so it would be a -1. And then if you would get to pi and you would do y over x, you would have gotten 0 again. Okay, so notice that here this VA occurred in the middle. So what we're going to do here is we're going to shift things a little bit. Okay, so our period is still going to be pi over b like with cotan. Okay, if you excuse me, if you would keep going with values, it would start to repeat itself again in just pi for the generic tan graph. Right, if there are other transformations, the b will dictate that. Okay, so your quarters, we're still looking at pi over 4. Now, in order to see a full section of this tan graph, we're actually going to shift it a little bit. Okay, so now we're going to make, this is key right here, 0 the midpoint of our table. So that way we can see a whole section of this graph. So let's put 0 in the middle here. So let's make this negative pi over 4, negative pi over 2, pi over 4, and pi over 2. Okay, so 0 is where we got 0. Pi over 4 was 1. Pi over 2 was undefined, so that was our VA. If you would go to negative pi over 4, you would still get 1 over 1, but now that's in quadrant 4, so that would still be 1, but it would, be a negative 1. And then if we go to negative pi over 2 is here, so we would get undefined there, so that would create the VA. So that way you can see, kind of like cotan, we have the VAs on the end again if we shift this over. So if we draw those VAs in, notice the pattern here is negative 1, 0, 1. And once again, you want to hug those asymptotes. So real quick, sorry, I should have had this done already. If you look at a full graph, this is just one period of the graph of tan. Right, you can see that this repeats itself. So we just graphed this section so that we could see a whole graph. If we wouldn't have moved it over and we had made 0 our starting point of our table, we would have just seen this portion and this portion. So that way, if we shift it, we see one full period of that. Okay, so now let's look at one that information's done to it. Oh, oops, sorry. Let's do domain and range, my bad. So range, you can see, is just like with cotan. It's negative infinity to infinity. It's the domain where we have to list where those asymptotes occur. So for domain, we're going to list where our, technically you could list negative pi over 2 or pi over 2 for your asymptotes. It doesn't matter. So if I do negative pi over 2 plus, notice it repeats itself after a period. So plus your period, which in this case is pi k. If there's no transformations, it's just pi. You are totally correct if you would have also done pi over 2 plus pi k. So it's whatever your period is. Sorry, this is kind of smushed. Okay, so let's look at one that has some transformations. So here, my vertical shift is up 2. My horizontal shift is right pi. My amplitude's technically 1. Technically, there's a 1 there. Now my period, like we said, it's pi over b. So pi over 1/2 is going to turn into 2 pi. Our quarters, if you take your period divided by 4 still, so that's going to be pi over 2. Okay, now this is where you need to be careful when you're setting up your table. This right here, and this is important, this is what you make your midpoint. Your horizontal shift becomes your midpoint. Okay, so we do 5 values, so the third value should be pi. And then from there, you want to count forward with your quarters. So this is technically 2 pi over 2, so 3 pi over 2, 4 pi over 2, which is 2 pi. And then go backwards, so subtract it. So this would be 1 pi over 2 and 0. That is important. Your horizontal shift is your midpoint for a tangent. Okay, so remember your endpoints are your VAs. And then the pattern for tangent is the opposite of cotangent. So -1, 0, 1, which makes sense because they're reciprocals. So this portion, if we would put in pi over 2, would come out to -1. So 2 minus 1 is 1. 0 would leave us with 2. And if it came out to 1, that would create 3. So let's label this guy. So put in your VAs. Pi. So we're at 1, 2, 3. Now remember, you want to keep this smooth and hug those asymptotes on the sides there. So my domain, x cannot be, now once again, you could start with 0 or you could start with 2 pi. So I'm going to say 0, x cannot be 0, plus whatever my period is. So my period in this case is 2 pi k. Okay? And then the range, it goes all the way down to -infinity for the y values and all the way up. So all reals -infinity to infinity. Okay? There are a couple problems here at the bottom, 2 with tan, 1 with cotan. Let me know if you guys have any questions or you need any help. I hope you're doing well.